Alright, in this lesson we're going to talk about how do you actually find T-critical. And again, at the top you see the label of this appendix B out of your textbook. So this is in reference to the T distribution. And nextly you see a couple of pictures. On the left hand side you see the picture with the shaded regions on both ends of the distribution. So the numbers on the left-hand side in this table will be for two-tailed or non-directional tests, and then the picture on the right is the shaded area, or the area of rejection is only on one end of the distribution, so it is for a one-tailed or a directional test. So the three things, and hopefully this is a little bit of a review, but the three things that you need to know specifically to find the critical value for a t-test are your alpha level, or the level of significance, the number of tails, and then degrees of freedom. And you might want to jot a few notes down about this. Degrees of freedom is abbreviated DF, and so here are kind of some definitions of degrees of freedom, if you will. Degrees of freedom is a value that indicates the number of independent pieces of information that go into the estimate of a parameter. And a couple of things in there that are important. Remember, because we don't have access typically to everyone in a population, we have to estimate population parameters. So the degree of freedom, or degrees of freedom, is a value that indicates the number of pieces of information that go into the estimate of that parameter. Basically, each item that is estimated costs, if you will, 1 degree of freedom. Kind of another definition, the number of values in a final calculation that are free to vary. So a lot of people kind of like that definition. Basically, if you knew that the sum of some numbers added up, let's say, to 16, and you had 4 numbers, after you added up the first 3, you would, by knowing what the total score was, know what that third item was. So there was, in that instance, there's 1 degree of freedom, because only that last item is free to vary. We've actually used degrees of freedom previously, we just didn't really call it by that term. Think back to the first module, we calculated the standard deviation in that module, and what we were doing in essence was estimating the population standard deviation from our sample. We just didn't really talk about it at that time, and to do that we had to change sums of squares, or variation into variance, and to do that, again, we divided our variation by n minus 1, and so n minus 1 is actually a form of degrees of freedom. We did talk about it there that we were also attempting to make it an unbiased estimator of the population standard deviation. Also know that degrees of freedom are different for different statistical tests. You're watching this, should be watching this after we have talked about independent samples t-test, and so you now know that the degrees of freedom for an independent sample t-test is the number of subjects in the first group plus the number of subjects in the second group minus 2, so n1 plus n2 minus 2. I don't want to get super bogged down in what is degrees of freedom, but I think the definition of it's the number of independent pieces of information that go into an estimate of the parameter. Think about the fact that when we're doing an independent sample t-test, we are estimating the mean and standard deviation of 2 populations. The population, for the example that you just went through, of the scented memory group, and the population of the unscented group. And so that's why the degrees of freedom for that test are n1 plus n2 minus 2. All right, so let's look at the table. In that particular test, we were doing a non-directional test. Our alpha level was 0.05, And our degrees of freedom in that case is actually not on here because it was 16. So let's pick another example. Let's say that we're doing a two-tailed test, 0.05, our alpha is 0.05, and we have 11 degrees of freedom. What is your critical value? And hopefully you were able to move over to the left-hand side of the page because it's a two-tailed test, and you found a significance level of 0.05, and our 11 degrees of freedom gave us 2.201. Let's do another one. Let's say that we're doing a one-tailed test, 0.01 and 15 degrees of freedom. So take a second and find that. And what you'll see here is that you have 2.602 is our critical value. Okay? Sometime in the future, after this next test, so in Module 5, you're going to be doing a something called a dependent t-test, and the degrees of freedom for a dependent t-test is n-1. So I'm not going to get into the specifics about that right now, but the 2 degrees of freedom that you need to latch onto are n1 plus n2 minus 2 for an independent t-test, and degrees of freedom for a dependent t-test are n-1.